Let's revisit that graphing problem that we put big question marks on before, f of xy equals x squared plus y squared. This time, let's sketch level curves to start out. So we're dealing with a function z equals x squared plus y squared. And let's use, it's up to us to determine which heights we're going to use for our level curves. Notice that z cannot be negative, right? Because x squared is positive, y squared is positive, and if you add two positive numbers, you're not going to get a negative. The smallest z could be is 0. So let's start there, and let's use 1. And I'm going to pick z values that are convenient. So I'm going to pick 4 and 9. And you'll see why in a little bit, why those are convenient. So anyway, when z equals 0, putting in a 0 for z, we have 0 equals x squared plus y squared. That tells us that x and y are both 0 for reasons that I explained in the last video. What about when z equals 1? Then we have 1 equals x squared plus y squared. So that is a circle centered at the origin with radius 1. What about when z equals 4? Then we have 4 equals x squared plus y squared, which is a circle centered at the origin with radius square root of 4, which happens to be 2. So the reason I picked 4 is because, well, the reason I picked both 1 and 4 is because they're perfect squares. So it's easy to see what the radius is. And then what about when z equals 9? Then we have 9 equals x squared plus y squared, which is a circle, again centered at 0, 0, with radius square root of 9, which is 3. So that's what I meant by picking convenient values. I'm picking perfect squares because I know I'm going to end up square rooting them. Now, what does this look like? Got a circle of radius 3, circle of radius 2, circle of radius 1, and then I have that single point in the middle. Oops. So these are our level curves. And we can put in there, well, first of all, let's put in their coordinates. So that's x, that's y, this is 3, this is 2, that's 1. And if we want, we can also put in labels to indicate which of these contour lines is at which height. So we can put in z equals 1, z equals 4, and z equals 9. Now, if you're good with graphing in 3D and skillful and careful, you can figure out what this shape looks like. But let's face it, graphing in 3D is hard. So there's a bunch of possibilities here. Just because we have we know that we have circular cross sections doesn't tell us a whole lot. I mean, we could have the upper half of a sphere. That would have circular cross sections, or it could be a cone shape. Which would also have circular cross sections, or it could be something more like this. Or it could even be something totally crazy, like, I don't know, this, with circular cross sections. How do we know which, if any of these, are the right shape? They all have circular cross sections. Well, again, if you're really good with graphing in 3D, you can maybe come up with what this is supposed to look like. But there is something easier we can do. There's a tool we've already developed back when we were graphing planes, and that's traces. Remember, traces are the curve you get when you look at how your graph intersects one of the coordinate planes, whether the back wall, the left wall, or the floor. So let's look at the back wall, which is the YZ plane. Now on the YZ plane, X is 0. So let's put a 0 in for X. Let's see, what are we dealing with here? I've forgotten. Okay, so we have Z equals X squared plus Y squared. If we put in a 0 for X, we get Z equals Y squared. That's a perfectly ordinary parabola that we can draw on the back wall. Let's also look at the left wall, which is the XZ plane. And on the XZ plane, Y is 0. So we'll have, if we put in 0 for Y, we have Z equals X squared plus 0 squared. In other words, Z equals X squared. And that's also a perfectly ordinary parabola. And if we look at the floor, in other words, the XY plane, on that plane, Z is 0. And if I put a 0 in for Z, I get 0 equals X squared plus Y squared. We've already looked at that and determined that that means that X and Y are both 0. So we just have a point. So to recap, for the back wall, we're going to have a parabola. For the left wall, our surface is going to intersect it in a parabola. And then on the floor, our surface is going to intersect it at the single point 0, 0. Let's put the pieces together and see what we've got. So we've determined that the trace on the back wall is this parabola, y equals c squared. In other words, when that back wall slices through our surface, the cross-section we'll see is a parabola. Similarly, we've determined that when the left wall, the XZ plane, slices through our surface, we will also get a parabola. Finally, we also know that the cross sections will be circles. And that gives us our final shape. This, by the way, is called a paraboloid. You don't need to know that word, but in case you run into it in the future, what it means is a surface where the vertical cross sections are parabolas and the horizontal cross sections are circles. I hope this helps. As always, let me know when you have questions.